Hi everyone, this is Christiana Malta, and for today's video activity, I'll be solving sets of problems under AC circuit. This is our video assignment number 2 in Enhancement Course 1. And for our first problem, we have here number 3. Three parallel branches respectively contain R is equal to 300 ohms, L is equal to 0.50 Henry, and C is equal to 10 microfarad. Given the voltage V is equal to 200 sine 1000 T, determine whether the total current lags or leads the voltage and by how much. So, we have here our diagram and our given. So, the first thing that we need to do is to change the unit of these two into ohms. And to do that, we'll use this formula for, let's have first our L. So, we will change this one into inductive reactance. So, by using this formula, XL is equal to G omega L, and for our omega, based from the given, it is 1000 rad per second. So substitute 1000 here and 0.50 Henry. So I will get J500 for our inductive reactance. So for capacitive reactance, XC is equal to negative J 1 over omega C. So, negative J, 1000, and our 10 microfarad, let's convert that one into a farad by multiplying times 10 to the power of negative 6. So, we will get negative J 100. Okay, so, it is converted into ohms. So, and the next thing is to find the RMS of the voltage. The RMS of the voltage by using this formula. V RMS is equals to Vm over square root of 2. And then 200 over square root of 2. We will get 141.421 volts. And then from that, we will be able to find the current in each branches. So first, let's have the current in resistance. So we will have IR is equal to ER over R. So we have 141.421 divided by 300, and we will get 0.4714 ampere angle 0 degrees. And then the next is to find the current at the capacitance. So we have EC, XC, we have 141.421, and our XC is negative J 100. So we will get, for our IC, we will get 1.4142 angle 90 degrees. So we'll have this answer in a polar form. And then the next current is the current in the inductance. We have EL over XL, 141.421 divided by our XL is J500. We will get 0.2828 angle negative 90 degrees. So the last step is to find the total current, and to do that, we will just add all the current in the branches. So we have I total is equal to the current from the resistance add plus the current from the capacitance and the current from the inductance. So the current from the resistance, we have 0.4714 ampere angle 0 degrees plus the current at the capacitance 1.4142 angle 90 degrees plus the current at the inductance, we have 0.2828 angle negative 90 degrees. And for our total current, we will get 1.2256 ampere angle 67.38 degrees leading. So our answers are in polar form. So we have here letter D, 67.4 lead. Okay, so for our next problem, we have here number 83. A variable capacitor C is connected in parallel with an inductive coil of inductance 0.2 Henry and resistance of 10 ohms. The combination is connected across a 10 volt 60 Hz voltage source. Find the value of C, which will result in a minimum current from the source. So it is our diagram and our given. So first, let's find the value of our inductive reactance using this formula. XL is equals to 2 pi FL. So our frequency is given as 60 Hz and our L is 0.2 Henry. So our inductive reactance is equal to 75.398 ohms. So then find the value of capacitive reactance using this formula. 1 over XC is equal to XL over RL squared plus XL squared. 1 over XC is equal to our XL is 75.398 ohms or RL is 10 ohms plus 75.398 squared. The value of our capacitive reactance is 76.72 ohms. And now let's find the value of C, which is our capacitance using this formula. XC is equal to 1 over 2 pi FC. Our XC is 76.72 ohms is equal to 1 over 2 pi. Our F is given as 60 Hz and our C. So our capacitance is equal to 3.457 times 10 to the power of negative 5, that is in farad, and the choices looks for microfarad, so let's convert this one, multiply to 1 million, so we have 34.557 microfarad, and that is letter D. Okay, so for our next problem, we have here number 66. A series circuit consisting of a 30 ohm resistor and a 4 microfarad capacitor is connected in parallel with a variable inductor. For what value of inductance will the circuit be in resonance if the frequency of the source is 1200 Hz? So it is our diagram and our given. So first, let's find the value of a capacitive reactance using this formula. XC is equal to 1 over 2 pi FC, 1 over 2 pi. So our frequency is given as 1200 and our capacitance is given in microfarad. So let's convert that one into a farad by multiplying times 10 to the power of negative 6. So we will get, for our capacitive reactance, we have 33.1572 ohms. Next, let's find the value of our inductive reactance using this formula. 1 over XL is equal to XC over RC squared plus XC squared. 1 over XL is equal to our XC is 33.1572. Our RC is 30 ohms plus 33.1572 squared. For our XL inductive reactance, we have here 60.3006 ohms. So from that, we'll be able to find the inductance. So from this formula, XL is equal to 2 pi FL. We'll derive that one. L is equal to XL over 2 pi F. Our XL is 60.306 divided by 2 pi. Our frequency is 1200. So for our inductance, we will get 7.999 millihenry or 8 millihenry. So it is letter D. And for our next problem, we have here number 32. A load draws a current I is equal to 10 cosine omega t plus 30 degrees from a voltage E is equal to 220 sine omega t plus 30 degrees. Determine the complex impedance of the load. So it is our given. So since our given waveform are not consistent, so we will choose which of these two atong i-lessen. Either ang cosine here ma-change into sine or ang sine here ma-change into cosine. But in this case, I choose to change the sign here into cosine. So, consistent na siya dira din siya mausab. So, we all know that cosine A is equal to sine 90 minus A. So, it will become 220 cosine omega t plus 90 minus 30 degrees. So, 220 cosine omega t plus 60 degrees. So, same na sila, cos, puro cosine. So, the next step is to find the complex impedance using this formula. Z is equal to Vm over Im. And then, 220 angle 60 degrees divided by 10 angle 30 degrees. And we have 19.05 plus J11. And it is letter B. Okay, so for the next problem, we have here number 100. A 400 volts, 200 Hz AC source is connected in series with a capacitor and a coil whose resistance and inductance are 20 milliohms and 6 millihenry respectively. If the circuit is at resonance, find the capacitance of the capacitor. So, we will be able to find the capacitance of the capacitor using this formula. The frequency of the resonance is equal to 1 over 2 pi square root of LC. Substitute all the given to the formulas. We have here 200 is equal to 2 pi square root of our L is given as millihenry, and we'll convert that one into Henry. So it will become 0.06 multiplied to C. And we will get 1.0554 times 10 to the power of negative 4 farad. And then we will convert that one into microfarad by multiplying 1 million. So it will become 105.54 microfarad. And that is our capacitance. It is letter A. Okay, so for the next problem, we have here number 49. A series or LC circuit consists of an 80 ohm resistance, a 0.3 Henry inductance, and a 50 microfarad capacitance. The combination is connected across a 120 volt variable frequency source. At what frequency will the current be 1.2 amperes at lagging peak? So it is our diagram. So first, let's find the value of our impedance using this formula. Z is equal to voltage over current. So our voltage we have here 120 over 1.2. So we have 100 for our impedance. So using this formula, Z is equal to square root of R squared plus omega L minus 1 over omega C squared. Okay, now we'll be able to find the frequency using this one. So substitute the given value of our impedance here. We have 100 is equal to R is 80 ohms plus omega L minus 1 over omega C squared. Great. So let's multiply 2 here to eliminate the square root. So 100 here will become squared, and then 80 squared plus omega L minus 1 over omega C squared. And after that, let's transpose this one. So pagsamahin natin yung mga constant. So we have here 100 squared minus 80 squared is equal to omega L minus 1 over omega C squared. And after that, let's put square root here. So 1/8 omega L minus 1 over omega C. So let's put square root here, and the squared here will be gone. So from this part, let's multiply 1 omega. this one. Our goal is to eliminate this one because our goal is to have a omega squared and a variable that has a 1 omega. So let's multiply 1 omega here. So this one will become square root of 100 squared minus 80 squared omega is equal to omega squared L minus 1 over C. So let's arrange the equation. So we'll have here omega squared L minus square root of 100 squared minus 80 squared omega minus 1 over C is equal to 0. And now let's substitute the given inductance and capacitance here in our equation. So for our inductance, we have 0.3 Henry minus square root of 100 squared minus 80 squared is 60 omega. And our given capacitance is 50 microfarad. So let's convert that one into a farad by multiplying times 10 to the power of negative 6 is equal to 0. Omega squared 0.3 minus 60 omega. 1 over 50 times 10 to the power of negative 6 is negative 20,000 is equal to 0. So let's plug this equation into the calculator using mode equation 3. After plugging that one, we'll be able to find the roots, two roots rather. One is 376.887 and the other one that has a negative value of 176.887. So let's use this one because this one is absorbed. And by using this formula, omega is equal to 2 pi f, we will be able to find our frequency. Frequency is equal to omega over 2 pi. So our omega is 376.887 over 2 pi. So our frequency now is 59.98 hertz or 60. So let's say if we have it is letter A, 60 hertz. And for our next problem, we have here number 117. An ordinary household outlet of 110 volts RMS at 60 Hz is connected to a series circuit consisting of a 8 ohm resistance in an inductance of 0.0531 Henry and a capacitance of 189.7 microfarad. Calculate the complex power. So it is our diagram for the given problem. So let's find first the inductive reactance. So XL is equal to 2 pi FL. So 2 pi, our frequency is 60 Hertz and our given inductance is 0.0531. So for the inductive reactance, we will get 20.018 ohms. So next, let's find the value of our capacitive reactance. So XC is equal to 1 over 2 pi FC. So XC is equal to 1 over 2 pi. Our frequency is 60 Hertz. Multiply to our given capacitance, which is in microfarad. So let's convert that one into a farad by multiplying times 10 to the power of negative 6. And then we will get for our capacitive reactance, we have 13.98 ohms. Next is to find the impedance using this formula. Z is equal to R plus J XL minus XC. So we have here our resistance, which is 8 ohms plus J. XL is 20.018 ohms minus 13.98 ohms. So for our impedance, we will get a 8 plus J 6.038. Let's try to find the current using this formula. I is equal to V over the impedance. So our voltage, which is 110 over 8 plus J, 6.038. So for our current, we will get 10.97 angle of negative 37.4. Let's try to find the value of the complex power using this formula. S is equal to voltage times the current conjugate. So the voltage here and the current will be multiplied, and then the angle of the voltage and the angle of the current will be added. So for the voltage, we have here 110 angle 0 degrees, and then for our current, we have here 10.97 angle negative 37.04. So for our complex number, we will get 963.206 minus J727. So that is our complex power. So let's try to see if we have that on our traces. So it is none of this, I guess.